let's talk about building something amazing. Today, we're going to be architects. We're going to build our very own secure private fortress for our applications. But here's the catch. We're building it right inside the huge public world of the AWS cloud. Let's get into it. I mean, it's a pretty good question, right? You're in a massive shared space. So how do you keep your stuff private and secure? Well, that is the exact problem that the AWS Virtual Private Cloud, or VPC as you'll hear it called, is built to solve. It's the key to carving out your own isolated, protected network. So just like any big construction project, the very first thing you have to do is claim your piece of land and, draw the property lines. And in the cloud, that's exactly what we're doing first, carving out our own private corner. And here's our deed to that land, the Amazon VPC. Seriously, just think of it like that. It's your own private plot of land in the enormous AWS landscape. This is the foundation of our entire virtual fortress. It's a space where you and only you get to make the rules. Now, of course, every plot of land needs an address, right? For your virtual land, that address is something called a CIDR block. This range of private IP addresses, something like 10.0.0.0/16, is basically the unique street address for your entire property. It tells everyone, hey, this is where my fortress begins and ends. So how do you get one of these? Well, AWS gives you a couple of options. You've got the default VPC, which is kind of like a prefab model home. It's all set up and ready to go, which is great for getting started fast. But for our fortress, nah, we want a custom VPC. This is our own custom blueprint. It gives us total, absolute control over every single detail. Okay, so we've got our land. But we can't just throw everything into one big open field. That would be chaos. We need to zone it for different purposes. So now we start dividing our property into specific areas. And these zones, they're called subnets. A subnet is really just a smaller chunk of your VPC's total address space. But here's the crucial part. Each subnet lives entirely inside one single AWS availability zone. So by creating subnets in different zones, you're building in reliability and high availability right from the get-go. Pretty smart, huh? And you gotta know, not all zones are created equal. You have a public subnet, which is like the welcome center or the public-facing storefront of your fortress. It's connected to the internet so people can get to it. Then you have the private subnet. This is the secure vault. It is completely isolated from the internet, which makes it the perfect, safe place to keep your valuable databases and your critical backend services. Okay, this is one of those little insider tips that's super useful. In every single subnet you create, no matter the size, AWS automatically holds back 5 IP addresses for its own internal use, for things like the router and DNS. It's a small detail for sure, but trust me, knowing this is absolutely crucial when you're planning out your network. All right, so we have our land, we have our zones, but how does traffic get from point A to point B? From the welcome center to the vault? Or even find the main gate to get out? We need to build some roads and put up some signposts. In the world of VPCs, that means we're creating route tables. A route table is basically the GPS for your whole VPC. It's just a simple set of rules that tells all your data packets exactly where they need to go. Anytime a packet of data tries to leave a subnet, it looks at the route table to get directions, whether it's headed to another part of your fortress or all the way out to the internet. And this table here shows you exactly how simple it is. For a public subnet, you really just have 2 main rules. The first one says, hey, if you're trying to get to an address inside our property, that 10.0.0.0/16 range, just stay on the local roads. The second rule, that 0.0.0.0/0, is the catch-all. It says for anything else, any other destination in the universe, head for the main gate, which in our case is the internet gateway. So we've mentioned that main gate a few times. Well, every fortress needs controlled ways to get in and out, right? You can't just have holes in the wall. In a VPC, these are your gateways. Let's take a look at the different kinds of doors you can install on your fortress. So first up is the big one, the Internet Gateway, or IGW. This is the main gate of your fortress. You just attach it to your VPC, and boom, you have a 2-way connection to the public internet. It's what lets traffic flow both in and out. But wait, what about those things in our private, secure vault? Sometimes they need to get out to, say, download a security update. For that, you use a NAT gateway. Think of this like a high-security exit-only door. It lets your private stuff get out to the internet, but it will absolutely not let anyone from the internet start a conversation back in. And one more. What if you need to connect your AWS Fortress all the way back to your company's physical headquarters? That's what the Virtual Private Gateway is for. This thing creates a secure, encrypted tunnel, kind of like a secret passage, directly from your VPC to your own on-premise network. It's how you build a real hybrid cloud. Okay, the walls are up, the zones are marked, the gates are installed. We're getting close. Now it's time for probably the most critical step of all, hiring the security guards who are going to patrol the grounds and check everyone's ID. Now, your fortress actually comes with two different kinds of security guards, and they operate on totally different levels. You've got security groups, and you've got network access control lists, or NACLs for short. And let me tell you, understanding how these two are different is absolutely essential to keeping your fortress secure. So here's the breakdown, and I love this analogy. A security group is like a personal bodyguard that's assigned to one specific server. It's stateful, which is a fancy way of saying if it lets a conversation in, it automatically lets the reply back out without a second thought. A network ACL, on the other hand, is like a checkpoint guard at the border of an entire zone or subnet. It's stateless. It checks the ID of every single packet going in and every packet going out, and you have to write separate rules for both directions. And the security doesn't even stop there. You also have tools like VPC flow logs, which are basically the security camera footage for all your network traffic. You have IAM permissions, which control which of your people are allowed to be architects and change the fortress walls. And you have VPC endpoints, which create these private little tunnels to other AWS services, so you don't even have to go out on the public internet. So what's the big takeaway here? You don't pick one guard over the other. The best practice, the way the pros do it, is called defense in depth. You use both. The NACL is your first line of defense at the border, and the security group is the fine grained protection right at the server's front door. And there we have it, the complete construction checklist for your virtual fortress. Step 1, you lay the foundation with the VPC and its address. 2, create your zones with subnets. 3, draw the map with route tables. 4, build the gates. And finally, 5, you set the security rules with your guards, the security groups, and NACLs. By understanding these 5 core pieces, you've really leveled up. You've gone from just being a resident in the cloud to being its architect. You now hold the blueprint to design and build networks that are secure, scalable, and totally isolated in AWS. So your fortress is built, the gates are secure, the guards are on patrol. The only question left is, what are you going to protect inside? What are the critical applications, the valuable data that you're going to keep safe in there?